Richard James will present fraction tutorial 4. On this occasion, we do not have the large fraction bar. This is quite an appropriate way to begin this presentation. That is, by converting mixed numbers to improper fractions. So we have 3 ones, 3, and then 3 plus 1 is 4, and then we have the 4 as our new numerator, and the denominator will be the same. More, we have 3 and 5, 6. 6 threes, 18. 18 plus 5 is 23. 23 is the new numerator. The denominator is the same. I am sure that we have at least another one. 9 fives, 45. 45 plus 1 is 46. 46 over 9. No bracket was used in the statement of the problem, and we do not have to use any. As we have seen on a few previous occasions, we have situations in which brackets were used, but they were not completely necessary. I am happy that in this particular case, they are not necessary and they are not used. So no bracket was used in the statement of the problem, and we did not have to use any. We just need to make use of the fact that division takes precedence over addition, or subtraction for that matter. Therefore, since division takes precedence over subtraction, we will do the division first. Because division takes precedence over subtraction, we will take all necessary steps to complete the division first. Do the reciprocal of the division and change the division sign to multiplication. So there we have the division, and we will do the reciprocal, changing the sign from division to multiplication. And for the one that we are using here, which takes precedence over this one, which is the subtraction, so we are completing this operation first. We are making use of a common denominator of 23. So reduce by a common denominator of 23. So 23 into 46 is 2, and 23 into 23 is 1. Also, we have common factors of 3. So 3 into 6 is 2, and 3 into 9 is 3. Finish up by multiplying the resulting numerators and denominators. So we have 1 times 3 is 3, and 2 is 4. So we have 4 over 3 minus 3 over 4. And that we will complete on the next slide. Finish up by finding the difference between fractions whose denominators are what we call exclusive. And that we do by making use of the fact that the denominator of the answer will be the product of those two denominators. So 3 multiplied by 4 is equal to 12. And then we say 4 4, 16, and we say 3 3s 9, and find the difference between the two numbers. 16 minus 9 is equal to 7. So the answer is 7 over 12. This problem is providing us with a lot of fun, inclusive of subtracting a fraction from a whole number, which by now should be a lot of fun. Let us work on the improper fractions first. So we have 8 and 1/3. 3, 8, 24. 24 plus 1 is 25. 25 over 3. Then what do we have? 2 2's 4. 4 plus 1 is 5. 5, and the denominator is 2. Then what do we have? 2 minus 5 over 6. 2 minus 5 over 6. And then we know that this 2 may be written as 1 plus 1. And one of those will be 6 over 6. So 6 over 6 is 1. And this is the other one to make 2. So we have 1 and 6 over 6 to minus 5 over 6. And what will happen? 6 over 6 minus 5 over 6 will be 1 over 6. And this one is untouched. We have 1 and 1 over 6. And I know what we imagine that we'll do maybe on the next slide to convert that to an improper fraction. So 2 is equal to 1 plus 1, which is what we are making use of here. So the 2 is converted to 1 plus 1. Convert one of them to 6 over 6. So we have 1 and 6 over 6. So we now minus 5 over 6 from the 6 over 6 and we get 1 over 6. The other one is unaffected. The answer is therefore 1 and 1 over 6. Subtract the fractions whose denominators are exclusive and convert the other mixed number to an improper fraction. We have another mixed number, the one that we obtained, which is the one that we obtained by subtracting 5 over 6 from 2. So let's go straight ahead and make use of exclusive denominators. The new denominator will be the product of those two. Then we have the product of those two will be the next thing, which is 50. And then we have the product of those two, which is 15. And we will convert the other one to an improper fraction. So 6 multiplied by 1 is equal to 6. And then 6 plus 1 is equal to 7. So we will have 7 over 6. What do we do with that 7 over 6? We will do the reciprocal and change the sign to a multiplication sign. Invert the divisor and multiply instead of divide. Simplify the numerator of the fraction, then reduce by a common factor of 6 and then by a common factor of 7. So we have 50 minus 15 is equal to 35. This we obtained from the previous slide. And then what do we do next? Invert and multiply. Then we will go straight ahead and reduce by a common factor of 7. Into 7 is 1 and 7 into 35 is 5. Then we reduce by a common factor of 6. 6 into 6 is 1 and 6 into 6 is also 1. So what do we have? 5 multiplied by 1 is 5, and 1 times 1 is equal to 1. So 5 over 1, and that is equal to 5. We will begin with our threefold activity. Right, we are so accustomed to it that we can give it a name. Threefold activity. And we know the threefold activity: convert mixed numbers to improper fractions, enclose the upper set of fractions with brackets, and replace the large fraction bar with a division sign. So what do we do first? 4's 32. 32 plus 1 is 33. And that we put over 8. Then we have 3 times 4 is 12. To 12 we add 3 and we get 15. 15 over 4. Alright. And then if there's another one, 7 ones, 7. And 7 plus 1 is equal to 8. So 8 over 7. And as a matter of fact, notice that these brackets are different from these. No bracket was left in my solution. That would have caused the entire thing to be wrong. So what I've done is I have created 2 brackets when I was doing the slides and just insert them right there so that we will have the correct thing, because without the brackets it means that we are multiplying the 30 over 8 by 7 over 8, which is not what is intended in the statement of the problem. It is intended in the statement of the problem that we perform these operations first. So they should be enclosed in brackets. Until we have performed them, then we can eliminate those brackets. Of the 2 fractions in the brackets, one denominator is twice the other. 8 and 4. We may bring them to the same denominator by multiplying both denominators and the numerator by 2. So 15 over 4 is the one that we will adjust. So we will multiply the 15 over 4, the denominator by 2 and the numerator by 2. By multiplying the denominator by 2, we will have equal denominators, or we say common denominators. However, the fraction will not be the same as the one before. So in order to cause it to be the same as the one before, we also need to multiply the numerator by 2. And we will also make use of the fact that dividing by a fraction is the same as multiplying by its reciprocal. So let us take those steps. So we have 33 over 8 minus 15 over 4 times 2 over 2, because we are saying 2 times 4 is 8. Not enough, we need to multiply the numerator also, so 2 times 15 is 30. So we have 33 over 8 minus 30 over 8. And there now we are including the one that we are dividing by, so we multiply by the reciprocal. Multiply the denominators of 4 by 2 causes the fractions to have the same denominator. For equality to be maintained, the numerator must also be multiplied by 2. So we multiply the 15 by 2 also. And no doubt, in getting to this step, we say 33 minus 30. So 33 minus 30 is equal to 3. So we have 3 over 8. And in finishing up, we will have reduced by a common factor, but we do not have any common factor there. So we go straight ahead. There is no common factor by which we may reduce the fractions. So we finish up by multiplying the resulting numerators and denominators. So 3 7s, 21, and 8 8, 64. Nice. In primary school, we learned to add fractions or find the difference between them by adding their numerators or finding the difference between their numerators if they have the same denominator, which is easy. So they have the same denominator. 1 plus 3 is 4, 4 over 8. They have the same denominator, 2 over 7 plus 4 over 7. Add these, put that over 7. No problem. For subtraction, it is no different. 7 over 12 minus 5 over 12. 7 minus 5 is 2. Put that over 12. 4 over 5 minus 1 over 5. 4 minus 1, 3 over 5. No problem with that. We are accustomed to doing that from primary school. if the fractions do not have the same denominator, we were also taught to bring them to the same denominator. In the end, it is not the process that matters. It is getting the fractions to have the same denominator. When one denominator is a multiple of the other, the act is very simple. Use a simple multiplication to achieve that, and that we have been doing. And we have done that on this tutorial, and we have done that on previous tutorials. Multiply the denominator alone causes the fraction to be different from the one that you have before. Any number you multiply the denominator by, multiply the numerator by that number also. So here we have a particular case where we are saying 1 over 4 plus 3 over 8. To get the same denominator, we multiply the 4 by 2 to get 8, but we need to multiply the numerator also. So that turns out to be 2 over 8. So see, we have that 2 times 4 is 8. And we need to multiply the numerator also, so that is 2 over 8. So 2 over 8 plus 3 over 8, and that is very simple. 2 plus 3 is 5, so 5 over 8. We have another one. 4 over 9 plus 2 over 3. The 2 over 3, we have 3 to multiply by 3. The result is 9. And we need to multiply the numerator by 3 also. So this 2 over 3 may be converted to 6 over 9. And that is easy. 10 over 9 when we add those numerators. What steps may we take if the denominators are not so simple? None is a multiple of the other. So they are not multiples of each other. One is not a multiple of the other. So let us say that we have a quarter and 2 over 3 to add together. The common denominator is 12, which is the smallest number that 4 and 3 can go into without leaving a remainder. The LCM, the common denominator, the least common denominator. So we do what it takes for the two denominators to be 12 and do the same with the numerators. Now we are targeting 12 is the new denominator. If we have 4 here, to get 12 we multiply by 3. So we multiply the numerator by 3 also. We have 3 here. To get 12 we multiply the denominator by 4. So we multiply the numerator by 4 also. So that turns out to be 3 over 12 plus 8 over 12. And that is easy. 11 over 12. There we have another one. In the previous example, the denominators were exclusive. That means that they exist in such a way that they do not have common factors. So the denominators did not have common factors. This time they have common factors. Well, they have a single common factor. Or we're not thinking about 1, because 1 is a factor of every number. So they have a common factor of 3. So this time they are not exclusive. The common denominator is the LCM of the denominators, which is 18. The lowest number that 6 can go into and the 9 can go into without leaving a remainder, and that is 18. Do what it takes for each denominator to be 18 and adjust the numerators appropriately. To get 18, we multiply 6 by 3 and 9 by 2. Adjust the numerators appropriately. So the target denominator is 18. To get 18, we multiply this one by 3. So we multiply this by 3 also. To get 18 from this side, we multiply the 9 by 2. So we multiply this by 2 also. So we have 15 over 18, 4 over 18. And that is 19 over 18. And that can be done as simple as that. The method is not a shortcut. It is just getting the fractions to have the same denominator. Some might even go as far as saying that it does not look any way shorter than the one we are accustomed to from primary school. The method that I am demonstrating is not a pen to paper method. It is a process that may be carried out mentally. At this level, we should not limit ourselves only to what was taught in primary school. We may be innovative, developing methods that are simpler and quicker, as the most important thing is to obtain a common denominator. So these methods that I'm showing here on the screen is methods that you may apply mentally when you are adding fractions. These are not methods that are necessarily to be written down on paper when you are manipulating fractions. Well, we have them written down on the screen, but that is because we need to demonstrate it to you. That is why we have them right there. Again, threefold activity may also be used in the first step of this problem, and we know that already. Converting mixed numbers to improper fractions, enclose the upper set of fractions in brackets, and replace the large fraction bar with a division sign. Seven threes, 21 plus 1 is 22 over 7. And we have 7 twos, 14. 14 plus 6 is 20. We will find the difference between the two fractions by making use of exclusive denominators, and we will find the reciprocal of the divisor, at which time we will change the division sign to multiplication. So 22 over 7 minus 2 over 3. The new denominator will be the product of those two. Then 22 times 3 is 66. Then 7 times 2 is 14. And then we have the divisor right here, which is 20 over 7, and we will invert and multiply. Of course, 66 minus 14 is 52. We will put that over 21, and we multiply by 7 over 20. And we have some common denominators, as a matter of fact, 7 and 4. So 4 into 20 gives 5. And 4 into 52 gives 13. Then, away with that 7. 7 into 21 is 3, and 7 into 7 is 1. Then we will say 13 multiplied by 1 is 13, and 3 5s 15. Nice. As we are coming to the end of this one, some candidates are shouting hip hip hooray. No threefold activity on this occasion. Students are happy for that. We no doubt have to go through converting mixed numbers to improper fraction, but no threefold activity on this occasion. There is no large fraction bar, and brackets are not necessary because multiplication and division take precedence over addition and subtraction. We will perform the division or multiplication activity first. So we will do this one first, but do not forget that we have mixed numbers. So 3 ones, 3 plus 2 is 5 over 3. Do we have another? Yes. 8 to 16 plus 1 is 17 over 8. And what do we do next? Because division takes precedence over subtraction, we will take all necessary steps to complete the division first. So do the reciprocal of the division and change the division sign to multiplication. Do that first. What do we do next? Next we will reduce, if possible, the fraction. Yes, 4 into 8 goes 2 times, and 4 into 4 is 1 time. And then we multiply 17 multiplied by 1 is 17, and 2 times 3 is 6. Then we will finish up by adding fractions with exclusive denominators. So here we have denominators that are closely related, as 6 is equal to 2 times 3. This is therefore quite familiar ground. Multiply both denominator and numerator of 5 over 3 by 2, bringing the fractions to the same denominator and adjusting the numerator in order to preserve the value of the fraction. So this is quite familiar. Denominator is 6, this one is 3, so 3, 2, 6, multiply the numerator by 2 also. So there we have it. So we'll have 10 over 6 plus 17 over 6. Turns out to be not so bad, 27 over 6. And no doubt we may reduce 27 over 6 by a common factor of 3. So 6 divided by 3 is 2, and 27 divided by 3 is 9, and the result is 9 over 2. Here we have another number, but no problem, and the candidates are very happy that we do not have to go through another ordeal like this one.